Hi guys, welcome back. This is Professor Hank, and in this video I'm going to show you how to create records using structures. Okay, and let's get started. So 3 quick points and then we'll get to the coding part. The first thing is, you can have records, right? What's record? Record is just a logical collection of data, right? Student information, customer information, course information, whatever. And those records are going to have fields, right? Student name, phone number, address, etc. Okay, so you can combine all that information, put them into a struct, and then from there, as long as they're the same size, right? Because they are going to be fixed in length because we defined them in a struct, then we can store them into a file, okay? And what we'll do is we'll use the size of operator to figure out what the length of the record is, how many bytes it's going to take up, and then we'll use that information as part of our reading and writing process to files, okay? And we're going to be using binary files for this since records can have different field lengths themselves, right? So we're going to have record and structure. We're going to use the size of operator to determine the size of the record, the size of that structure in terms of its bytes, and we're going to be doing this with binary files. Okay, so first things first, we need to have a structure declaration for our record, whatever it could be. So maybe, like I said, student, okay, and student's going to have a few different fields here. We'll have the name of the student, and we'll make that a character array, so that way we can store it as a C string. Don't use string objects for this because a string object, it's an object, right? It's not going to be fixed. It's not going to be what actually gets stored in the file, right? In order to take an object and then write it to a file, you need to go through a process known as serialization, which is not what we're covering here in this video, and C++ doesn't have serialization built in anyway. So to get around that, not have to worry about it, we're going to use an array of characters and C strings. So we can do something like this. We can say name, right? And so then we'll allow 50 characters for that name, okay? And then you might have something like age, which is an integer variable, and then maybe your GPA, which will make a float, okay? So that'll be enough for what we're going to do for this example, and so we'll be able to store the name, age, GPA. Total size of this structure variable, right, when we declare one, should be 50 bytes for the array, plus 4 bytes for the int, plus 4 bytes for the float. So, and that would be, 58 bytes total, right? So we got that defined. Now let's create a struct variable, a student variable. Okay, and I'll just call it student stu, not student, student, and I'll initialize it with some info here. Right, so Hank, and then age, and then, well, I'm getting old, and then GPA, 3.58, right? And then from there, what we're going to do is we're going to take that record, just the one for this, just to get us started here, and we're going to write that to a binary file, right? So we're going to have to create an F-stream object, okay, which I'll call F, and then we'll have to try to open it, okay, and we'll call this records.dat. Now, you can name files anything that you want, right? Just because I have .dat on here, there's nothing special about that other than the fact that a human could look at the file name and go, oh, .dat, that's probably data, right? The operating system doesn't care. Your program doesn't care. There's nothing intrinsically special about that other than the fact, Windows can associate file extensions with different types of files and whatnot, but just know you can name the file whatever the heck you want, right? It doesn't have to be .dat. Okay, anyway, so records.dat, and then we're going to open this for writing, and we want to open it in binary mode. Okay, in binary mode. So this is going to allow us to do a single write that's going to take this entire record and put it in the file. Okay, so let's see. So let's verify that the file actually did open. Okay, and if it opened, and only if it opened, are we going to do our writing and then close the file. F.close. Okay, and then otherwise we'll go ahead and print out an error message, letting the user know something bad happened. Okay, so now we're going to do the write. Okay, so to do this, what we're going to need is we're going to need to use the write method that's provided with an fstream object. And that thing, remember, takes two arguments. The first thing is going to be the memory location. That's the source of the data that you want to write to the file. And then the second argument is going to be how many bytes you want to write to the file. And that's where size of is going to come in. Okay, now, since what I'm writing to the file isn't a character, I have to use casting. I have to do some casting here. And in C++, the recommended operator or casting operator here is reinterpret cast. Okay, so that's going to want to be cast as a character pointer. Okay, and what we're going to have to do is we're going to have to specify the memory address of where the variable is at. So I'm going to use that address operator. Okay, so that will basically say, hey, let's go ahead and treat the memory address of Stu not as a student memory address, but as a character address, right? It's required for the read and write methods for the fstream object when you're opening in binary mode. Okay, and then the second argument that we need here is going to be how many bytes it's going to be. Right now, we counted in our head how many bytes this thing should be. Right, there should be 50 bytes here, and then there should be 4 and 4. Thing is, though, is that some compilers, they like to pad the size of structures during the compilation process. So even though this is 58 bytes, some compilers like to bump that up to the next multiple of 16, right? So they might bump it up to 64 or 128. So you can't, it can mess you up when the compiler does that, right? So you don't have to worry about it. So that way your code is always portable. You can just use the size of operator. You don't have to do that counting. You don't have to worry about any weird stuff that happens by the compiler. Okay, don't have to worry about any strange happenings. Okay, so how big is this thing going to be? Well, if I use size of and I pass it my data type, my structure, then this is going to calculate it on the fly for us, and we don't have to hard code in this integer value. Okay, so let's go ahead and compile and run it. Okay. All right, so there's their output. Now, we didn't print anything, right? So that means that the error, the cout statement never executed, so it must have wrote something. Now, let's go open up the records.dat file. So I'll just go ahead and open it up. So here I'm in my project folder, and so if we right click on this, look at properties, you can see that it's 60 bytes, right? So we know that something actually did right there, which is good, but you'll notice that it's 60 bytes, right? When we first did that calculation in our head, we calculated it out to be, what was it, 58 bytes, right? Because we had 50 bytes for the character, and we had 4 for the integer and 4 for the float, right? So you can see that the compiler did some kind of weird stuff here. Okay, so let size of handle it, and then we don't have to worry about counting that stuff out on our own. But anyway, if I open this up with, say, Notepad, okay, let's go find you. Take a look and see what's in there, right? So we can see that you can read the Hank, and then there's all this extra space here, and then a bunch of garbage, right? Why? Because remember, binary files are not encoded for text. Okay, now the Hank part right here was all characters, and so these are 1 byte each, and so Notepad can recognize that and go, okay, sure, fine. But the rest of this stuff is the result of that float variable and then integer variable, so it looks like garbage, right? So that explains why it looks the way that it does. All right, so let's undo what we did. Let's do the reverse, right? So we wrote the student Stu record to the file, and now what we want to do is we want to undo that, right? So we'll read it back in to a different variable, okay? So let's go ahead and create student new stew. How about that, right? So I'll leave it uninitialized. So what's in its fields, garbage. And then what I'll do is we'll open up records.dat again. Okay, and this time we'll open it for reading in binary mode. Okay, we'll verify that it's actually opened, right, just like before. Okay, and we'll have an error message just like before. Okay, and once we're done with it, we'll close it, and then we're going to do the read. Now, the nice thing is that the read is pretty much the same syntax. I mean, we just change write to read, and then everything else is the same because we want to specify where we want the bytes to be written to in memory, right? So we'll do the casting thing again, and we'll say this time that we want it to go to the location whose memory address corresponds to or starts with this guy, right? Now, how many bytes do we want to read from the file into that location? Well, again, size of student, right? And so that'll match up, the size of this variable will match up the size of how many bytes we're going to read. And so in memory, there's going to be a chunk set aside, right, that we can now read into. Okay? Now, once that's done, we'll go ahead and print out the contents of our new stew variable, right? So we had new stew.name, and then we had new stew.age, and we had new stew.gpa. Right? So now if everything went right, it'd be useful if I actually learned to spell. If everything went right, we should see what we see, right? Hank 48, 3.58. So what did I just do? Right? I created a record, which I called student. I initialized it. I opened a file in binary mode for writing called records.dat. Verified it was open. If and only if it was open, I wrote the contents of my record, of my structure, to the file. I used size up to make sure that I got the number of bytes right. Okay, then once that was done, I created a completely separate student variable, right? Because the original one was stew, and then this one's now new stew. Open the file again, records.dat, this time for reading in binary mode, and then I did the opposite of writing, which is just reading. And so I read however many bytes a student is to the memory location whose address is at new stew, right? Or not at, but and new stew, right? And then once I did that, I was able to print out the contents of our student variable, right? So essentially what I did is I took the contents of this variable, dumped it into records.dat, and then I opened up records.dat, retrieved that information, and put it into the new stew variable right here, right? And then from there I printed it out. So it was a really indirect way of copying the contents of stew into new stew. Okay, now that's not all we can do. Okay, let me delete some of this stuff here. Okay, and what we can do is we can do this with arrays too, and this is really the power of using binary files, is that you can accomplish in one write operation what would take you many, or one read operation what would take you many reads and writes with text files, right? Because you can imagine that if I was using text files for this, I'd have to do 3 different writes. I'd have to write the name, I'd have to write the age, I'd have to write the GPA. Now what if I had an array of 100 students? Then I'd have to do 300 writes to the text file. Okay, but if I have a binary file of 100 students, I only have to do 1 write. Okay, but anyway, so let's create an array of students, okay? But I won't do 100, just to be merciful. And we'll just do, I don't know, 3, right? That should be good enough. So student, old students, size, and then I'll use an initialization list here. Okay, just to initialize it really quick. Okay, so we'll do Hank again, my age, GPA, right? We'll do another person, Tom, their age 25, their GPA 2.50, right? And then we'll have one more student, Rick, right? And they'll be 22 and they'll have a 3.90 GPA. How about that? Okay. So that'll initialize our array of students, okay? And then we'll do a similar kind of thing. We'll take that array and we'll dump it into a file that we'll call records.dat. And the thing is we'll do it with one write, one, not 9 as we would need with a text file, right? Because if it was a text file, we'd have to go student by student and then write each one of these fields to the text file. We don't have to do that here. Okay, so we'll dump all of our records, our 3 student records, into the binary file. Okay, so let's create an fstream object again. Okay, and then we'll open it for writing. Okay, we'll verify that it actually is open. And then if it is, we will process it and close it. Okay, so otherwise, we will print out an error message. Okay, so close, and here's what our write is going to look like. This is going to be new. So we'll have to f.write again, and we're also going to have to do the casting thing again, because we're going to write this array, and it's not an array of characters. Okay, if it was an array of characters, then we wouldn't have to do the casting. Okay, and so since an array is basically a pointer, right, a constant pointer, you know, we're not going to need to use the address operator here. We'll just be able to put the array name, right, as the value here, right? We don't need to get its memory address because it is memory address, and you're like, well, what are you talking about? What would happen if I was to do cout old students? You wouldn't see the contents of the array. You'd see a memory address, wouldn't you? Okay, now we need to specify how many bytes we want. Now we had 3 records, right? We have 3 elements in that array. There's 3 students in that array, so we'll do that size times the size of a student. Okay, so no compiler shenanigans and no worries about having to, you know, count out in our head and put in a literal value for the size. We'll just let the compiler handle it. We'll say the size of, you do your thing, we're not going to worry about it. Okay, so go ahead and compile that just to make sure we don't have any errors so far, and we don't, so that's good. So let's now read all of our records back from the file into a separate array for testing, right? I'm not going to write it back into the original array, because if something went wrong, I would know, right? If I printed out the contents of the original array, how would I know that anything bad happened? So we'll create another array, new students, that is size elements long, and I won't initialize this one, okay? And I won't initialize it, and we'll do the opposite. And this code's going to look pretty much the same, right? It's just a couple of minor changes, right? In this case, we're reading the records from the file, so we need iOS in, and we're reading, not writing, okay? And where are we going to put the data? Not into our original array, but into our new array, okay? And once that's done, I should have copied this array using a single write operation into records.dat, and then once that's done, I'll retrieve that information, all 3 of those records, from records.dat with a single read operation into new students, and then right now we'll go ahead and print out the contents of new students. Okay, so student s new students, use a range-based for loop here, and then we'll see out s.name, right? And then we'll see out s.age, and then we'll see out s.gpa. Right? So let's test it. If everything went right, we should see the contents of that array. And now notice, again, I read into the new students array. I'm printing out the contents of the new students array. What's in there? Well, until our read operation is successful, I don't know. Right? But let's see. All right, so this looks encouraging. There we go. So there's Hank, Tom, and Rick. Right? Hank, Tom, and Rick. So Hank, Tom, and Rick. So we have success. Okay? So that's how you can use structures to create records and then write them and read them, right? Store them and retrieve them from binary files. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.